Hello, my name is Colin Warrens and I'm doing Moment. I will start by using this rectangular figure as an example. What is this? Well, this is a door. For the purpose of this experiment, we will be moving the door to the left, so to open it. If we move the door from this point, it would be a piece of cake. Moving it from here, not so much. Why is that? Well, most of you have heard of the word torque before. Torque is essentially the same thing as moment, but seems to be used more oftenly when there is an axis or a pivot to be turned around, while moment is used more oftenly in a non-rotating situation. In aerodynamics, the pitching moment on an airfoil is the moment, or torque, produced by the aerodynamic force on the airfoil. If that aerodynamic force is considered to be applied not the center of pressure, but the aerodynamic center of the airfoil. Now, let's look at this airplane. Oh no, look, the airplane is head up. The wind is making the nose go up because it's just so powerful. The nose is about where the center of gravity is, and if that goes too far up, we are all doomed. But moment doesn't allow that. Because when the wind hits the airplane, it also reaches the back, which is very far from the center of gravity. In the back, there's something called a vertical stabilizer. This part of the plane stabilizes it by using the wind to create a force that is equal to the force moving it up, so that it makes the plane straight. Now, after the effects, you can see the plane is flying smooth again. The same thing applies for when the plane goes nose down. When it goes nose down, the wind reaches the back of the plane at the vertical stabilizer, and when it hits the vertical stabilizer, because of the distance away from the center of gravity, it is a lot easier for it to generate the same force that is pushing the plane down to make the plane fly smoothly again. As you can see here, the plane is going straight. The equation for moment is distance over force. Because as distance gets greater away from the center of gravity, the force needed to apply the same distance that might be close to the center of gravity is less. The coefficient for moment is moment over the dynamic pressure times the area times the chord. The coefficient for moment is most oftenly used when you're using a 2D model or using a 2D scale. And with that, I end my video. So, I did everything in the video, and the music is piano music by Mozart. We will end with some love from Harish.